Hey guys, I hope you guys are having a great day as always. Today what we are going to do is we're actually going to finish up our final week of notes. Today your lesson is going to cover section 12.5, which is multiplying and dividing our rational expressions. Alright guys, today we are going to take some notes on 12.5, which is multiplying and dividing our rational expressions. As a quick reminder, rational expressions are going to be your fractional problems. I thought we would start our lesson with something that we could probably easily do. In our example here, we have 6 over 8 times 2 over 3. And why I wanted to start off with this, though, is because those same skills that you're going to use to multiply your fractions here are going to be using on our rational problems as well. So because they are fractions, we're going to use that same skill set that we know that we could either multiply or divide our fractions. So let's really quickly just go over the different ways that we could simplify this problem, and then we'll go ahead and tie that into our new lesson today. All right, so let's look at this problem. So there are a lot of different ways, and why I want to talk about this though is because there's no one correct way that you need to solve. You can solve it in whatever way works best for you. So for example, if I was solving this problem here, a lot of us know that with multiplying we can cross cancel. So you might see that, okay, 3 goes into 6 twice. Or likewise, you might cross cancel the other way, that 2 goes into 8 4 times. We know that when we multiply fractions that we are multiplying straight across this way. So it would be 2 times the 1 on top, and then 4 times the 1 on bottom, which is 4. And then again, just like we practiced last week, we want to make sure we can simplify our expression or our fraction. We know that our final answer here would be 1/2. Another way that some of you might choose to solve problems like this is that you might simplify up and down first. 6 over 8, we know that can simplify to 3 over 4. All right, same idea here. You can cross cancel. 3 goes into 3 once. 2 goes into 4 twice. All right, and then again, multiplying across. On top, I have just those invisible 1, so 1 times 1. And then on bottom, 2 times 1. So again, we get that same answer of 1/2. All right, and then let's take a look at one last way that we can solve this. Another way, without cross canceling, we can just simply multiply across. On our numerator, 6 times 2 is going to be 12. On our denominator, 8 times 3 is going to be 24. And again, we can simplify that down to 1/2. And so what I wanted to point out to you guys here, though, is that you have the same problem. There are a lot of different ways to answer it, but notice that in each of those methods, we did get this simplified answer of 1/2. So whether you simplify up and down first, whether you cross cancel first, or whether you just multiply straight across and simplify at the end, again, you'll get the same answer. And so you can do that today as we are multiplying and dividing our rational expressions. All right, so as we start to multiply our rational expressions here, again, these are just the rules that we just went over. So again, we can look to cross cancel here, and that's going to make our problem a little bit easier to work with. We'll have smaller numbers. Remember, you can simplify up and down. So if, again, you have a fraction like we just had, 6 over 8, you could simplify that down to 3 over 4 before you multiplied. And then again, with our fractions, we're just multiplying straight across. So numerator times numerator, denominator times denominator. So the same skill set is going to be how we are going to solve our rational problems. For example, let's say we had something like this. 2x squared over 3x. And let's say times 6x squared over 12x to the third. All right. So again, here, a lot of different things you can do. You can look to cross cancel. So for example, you might say that 2 goes into 12 6 times. You might say that 3 goes into 6 twice. And so again, you are going to cross cancel your numbers. All right, you can also cross cancel your variables. For example, you might say that I have 1x down here and 2 up here, so that would leave me with 1. If you don't want to cross cancel your variables, you don't have to. You can simplify those at the end as well. So we'll take a look at a couple different ways that you can solve this. But let's say you did not cross cancel those variables here. What's going to happen is, let's do our numbers first. We have this invisible 1 times 2, so 2 on the top. On the bottom, we have this invisible 1 times 6, so 2, 6. All right, watch out with your exponents here. Remember, when we're multiplying, this means I have 2, and then I have times 2 more. And so what we did, we add those exponents. So here I have 4 on top. And on the bottom here, I have 1 and then 3. So again, I have 4 on the bottom. All right, but just like we saw before, we want to make sure that this final answer is in simplest form. So for example, you can simplify those numbers still. We know that 2 and 6 can simplify down to 1 over 3. And then again, here you notice that your exponents are the same, so they actually totally cancel out. So final answer here is going to be just a simplified 1/3. So again, going from something like this, we want to look for all the terms we can cross cancel or simplify, even our variables, and then we would get something like this as final answer. All right, I'm going to go ahead and put one up as an example. Feel free to try it if you like. I'll fast forward it so you can see the steps, and then we can go over the answer to this problem as well. All right, so here's the problem for you guys to try if you'd like to make sure that that makes sense to you. All right, so final answer here that I got was 3 over 4. Remember, the way I solved it is not the only way. I like to cross cancel my numbers, combine my variables, and then simplify. But like I said, you can simplify those variables in the problem as well. Guys, the next thing we're going to take a look at is multiplying when we have polynomials in our problem. And like any other lesson that we've gone over, it is never as easy as just the first part. So we are going to throw in some things that are going to make it a little bit more complex for us. So taking a look at this problem, what I want to point out to you is this though. You're going to notice that your squared terms are back. So anytime we have that quadratic, we know that, again, we want to try to break that down. And so we are going to be factoring here still. So just like we saw last week when we were simplifying, we want to do the same thing. We want to factor these problems down. That way we can cancel out any terms that are the same or any factors that are the same. So again, once you guys see those squared terms there, think factoring. All right, so let's go ahead and start to solve this problem together. I'm going to go ahead and move this up. And what we're going to do is we're going to just kind of break apart this problem. So let's start with the numerator here. Looking at this, I can see that both terms have a 3 and x. So I can go ahead and factor out a 3x here. So 3x. What that's going to leave me with inside the parentheses then would be x plus 1. All right, and then we'd go ahead and we'll do that then for our denominator here as well. And let's go ahead and factor that too. When I look at this, what I can see though right away is that there is a leading coefficient, but I can see that it's 4. And I also see that I have a 24 and a 36 here. 4 goes into both these numbers evenly, so I could actually pull out that 4. So I'm going to go ahead and do that first. So this would be 4, and then that would leave me with then x squared minus 6x plus 9. And then again, I'm going to just remind you, we want to break down as much as we can here. This term inside could actually be factored one more time. All right, so for those of you who can factor pretty quickly in your head, go ahead and use that skill here. If you struggle a little bit, that's okay, because remember, we can set up our x here, and what we're looking for is two numbers that are going to multiply to AC, which in this case is going to be 9, but then add to -6. Your two numbers here end up being -3 and -3. All right, so what we can go ahead and rewrite this term as is instead x minus 3 and x minus 3. All right, so same thing though, we want to make sure that we can break all of these up. So I'm going to go ahead and factor this top numerator of our next one here. So times, I'm going to go ahead and just factor this one in my head. It's going to end up being x minus 3 and x minus 1. All right, and then same thing, we can go ahead and simplify or factor out our numerator of this fraction. When I do that, I can see that I have an x squared and an x. They both have x in it, so x. It's going to leave me with an x minus 1 here. All right, so again, that's going to be your first step for these problems is I know that they look complex. However, we've been factoring and working with our quadratics for so long now that a lot of you guys can do them automatically. So again, look to break up everything first. That is our first step. All right, from here then, what's going to happen is actually very similar to what we did at this first part of our note. So we're looking to cross cancel. We're looking to simplify up and down. We're multiplying across. And so as we look at this problem now, again, look at the factors. What I would suggest is to simplify. Look for things to cross cancel because if you guys notice, there's a lot of things going on here. Look for the terms that are the same so that they cancel out. And now, what I want to remind you again, though, is when you're looking for a binomial, it has to be exactly the same to cancel out. So, for example, let's do this here. When I look at this problem, notice I have x minus 1 and x minus 1. They are the exact same binomial, and I am going to cancel them out then. All right, so same thing. Now looking across diagonally, I have an x minus 3 here and an x minus 3. So that's going to cancel out. What we could say we can also cancel out, for example, is notice here we have an x and we also have an x here. So I can cancel those out as well diagonally. All right, notice that it did not cancel out the number though. It just canceled out the x's because the x's are the same. All right, now if you look at this, there's nothing in common. I have 3 and 4. I have x plus 1 and x minus 3. So there are no more common factors here to cancel out. So your last step then is going to be to write what you have left. So for example, on the numerator, I have the 3, and then I also have the x plus 1 here. And then on the denominator here, I have the 4, and then I have the x minus 3 here. All right, and so this is actually going to be final answer. You do not need to remultiply this. You can leave this as is. So notice our answer again is in factored form, and that's going to be fine. So again, you want to have your answer in factored form. All right, guys, here is an example for you to try. Again, I will fast forward through it so you can see the steps, and then that way you can check to make sure that you understand as well. All right, guys, so here's final answer on this problem. W squared over 4 times W minus 3. Notice again here, I did not remultiply, so you can leave it in that factored form. And then again, watch out here as you cross cancel. I cross canceled my numbers too. So again, the numbers are separate from the variables, and you can cross cancel or simplify them as you would a fraction. All right, the last thing that we're going to take a look at in this section then is dividing our rational expressions. And just as a quick reminder, when we are dividing our fractions, what we're actually doing is going to be multiplying by that multiplicative inverse or multiplying by the reciprocal here. So same concept as any other fraction. Again, the only difference is that we're going to have those polynomials and those variables in our problem, but we're going to set it up the same way. So let's go ahead and take a look at an example together. All right, so here's our example. So 7x squared minus 7x over x squared plus 2x minus 3. And we're going to be dividing this by the fraction x plus 1 over x squared minus 7x minus 8. All right, so again, like I said, because this is a dividing problem, the first thing we actually want to focus on is being able to rewrite this in terms of multiplication. And then remember to do that. What this looks like is that same snap flip that a lot of times we go over or we talk about. And that's just to remember that the first term stays the same. So 7x squared minus 7x over x squared plus 2x minus 3. We're going to keep that the same. Instead of dividing, though, we are going to be changing that to multiplication. And then again, we're going to flip or take the reciprocal of that second term. So in this case, this is going to become x squared minus 7x minus 8 over x plus 1. So again, we're flipping that. All right, from here, what you should notice is that it is just our multiplication problem that we went over. So like we said before, first step here is to factor everything. All right, so first thing I did was I factored down all of these terms. Next step again though is remember you're going to start to look to cancel out the binomials or the terms that are the same. So in this case I can see that I have x minus 1 and x minus 1 that's going to cancel. I have x plus 1 and x plus 1 that's going to cancel. I don't seem to have anything else, so again last step then here is just to write down the factors that remain. So you have this 7x, you also have an x minus 8 in the numerator. And then on the bottom here, you have your factor of x plus 3, right? And that's going to be your final simplified answer here. All right, guys, and just like any other video, I'm going to give you guys the opportunity to practice and to make sure that makes sense. So if you'd like to try one more example, go ahead and do this one. Like I said, I will continue to do it as well, and then you can check your answer. All right, so hopefully that makes sense. All right, guys, hopefully that made sense. Remember, factor everything and then look to cross cancel. If you guys have questions, let me know. Remember, join the Zoom on Tuesday and Thursdays to come hang out, and I will see you guys for our last lesson. All right, and I'll see you guys for our last lesson on Wednesday. Bye, guys.